can be really easy to solve simultaneous equations by using graphs, and that's what we're using today. If you draw two linear graphs, their solution is found at the point they intersect. You can do the same for a linear and a quadratic graph. This time there are either two, one, or no intersections. Let's go through these questions. To find the intersection, we need to draw both graphs. So we're going to start with 2x plus y equals 7, which will look like this, and x minus y equals minus 1, which will look like this. You can do this by substituting in three values for x and find out what the values for y are. So you could pick 0, 4 and 8, and then you can draw the line from that. Or you can rewrite the equations as y equals mx plus c. C will be the y-intercept and m will be the gradient. For every one you go to the right, how far up do you go? The intersection is this point here because this is where the two lines intersect, and so it will be 2, 3. In this question it's slightly more difficult because we've got a quadratic, but let's start with the linear line first. It will look like this. So the equation is written as x equals y minus 6, but if we rewrote it as y equals mx plus c, it would be y equals x plus 6, and the gradient will be 1 and the y-intercept will be 6, so it goes through the y-axis at 6, and for every 1 we go to the right, we go up 1. Now quadratics are slightly harder to draw. What you can do though is you can put in some values, so substitute in a range of values between -3 and 1, and you can get a graph like this. And we can see that there are two intersections. There's one here which has the coordinates -2 and 4, and there's one up here which has the coordinates 1, 7. We're told in this question that there's one point of intersection, and we have a value of k that we need to find in the linear equation. So let's just write out both equations. Now I'm going to put brackets around the second one because it's y equals. We can actually substitute that into the first one. Then we can expand it and collect the like terms. Now notice that we can have the 2 plus 2k in brackets before the x. So we're creating a quadratic. Notice that our c value, our number value, is going to be k minus 5 at the end there. Now using this, we can use the discriminant. Because we know there's one point of intersection, so there's one solution, we know that the discriminant is going to equal 0. If you don't know what the discriminant is, we have done a video on the discriminant, so go and check that out. Our value for A will be k, our value for B will be that 2 plus 2k, and the value for C will be that k minus 5. And now we can just solve. So we know that k equals 4 or minus 4 over 28, which will cancel to minus 1 over 7. Let's finish on this question. Explain why y equals 3x plus 4 and y equals 3x minus 10 have no intersections. If you know, write it in the comments below. And you can also come to onmaths.com or click the link in the description where you can access all our free A-level papers and predictions and even save your scores with a free account. This video is part of a larger A-level course that you can follow along with at onmaths.com.